Okay, we're back today. I've got the vise mounted. This is the first run on the new Kurt DX6 vise. I already like it a lot better. It's a lot easier to get set up on the machine. It will hold the tooling fixture plate that I made before without any issues. And basically we're going to run a simple operation today. I'm going to face this down and square up the two cut sides. And I'm going to do this on the first one. I've got about 12 of these to do. And hopefully we don't mess any of them up. But this will be the tool holder for the smaller version of this. Basically this is the same board. But it's actually going to be a not made out of 2 1/2-inch pieces of aluminum. This is going to drop down to smaller material, and it'll basically be a little packet about that thick to actually hold this multiplexer. And for those of y'all that don't know what this is actually a you can think of it as a solid state relay. Each one of these, it's got 4 outputs. And this works on an automotive style, so I use this on my razor and my toy hauler to basically turn on and off loads remotely. So you've got some inputs that you can use really small wiring way off in the toy hauler or in the razor or what have you to activate these, and this is all solid state and doing current monitoring. And this really doesn't get super hot, but I do want to protect it. I went over this in other videos. This is conformal coated. This will run underwater without any enclosure, but it just beefs it up a little bit. The one that I have in the razor now is made out of a really thick material. It's about that thick. It's a little puck, and basically what we're going for is just decreasing the size to something that's a little more aesthetically pleasing and doesn't take up as much room. So we're going to get this job going. I'm actually going to show you real quick just how I set up a job from beginning to end. And I'll disconnect the camera and go around to the various parts of the machine and show you how I do that. Okay, the first thing that we did is we basically got the part in the vise. And that's pretty simple. Basically, if you remember from the prior video, there's a little ledge that's already machined. I've already machined one side of this plate. And basically the clamp, or the vise clamps onto that little ledge. And we've got that. And basically we've got our work coordinate offset is going to be, the work coordinate system is going to be based off of this corner. And it's basically going to come down and do a facing operation. It'll take a swipe, lift, take a swipe, lift. With this particular cutter, that's what gives me the best finish. So that's how we basically start the project, is you basically get the material into the machine. And this is basically what I do next. I've got some ops disabled here. This particular plate, I'm not going to drill it yet because this is not going to be a generic plate. Probably the last plate that I do, I'll do the drill operation and do my normal tooling plate. But all of these are blanks. And we've already done the bottom operation. That's what has the ledges. I'll just kind of flip this over so you can see it. So that's what the bottom looks like. And basically I usually do you know, a quick simulation just to make sure that that you don't have any errors. And that's what I was talking about on the face mill. It's basically going to come, retract, come over, retract, and that's what gives me the surface finish that I'm looking for. When everything's ready, basically I run this through post-process. For my particular machine, I am using the Fanuc post-processor, but it's slightly modified, and that's why that actually says personal post, because I have to modify the post-processor for my particular automatic tool changer. And basically from here we just save this to a USB key, and I'll take you over to the machine and show you how I actually get it to the machine. Okay, this is the USB key that we just wrote the the 1018 program to, and we're going to select the USB, and we're going to scroll down to 118 or 1018. That's our bottom program. And we're going to go into function and send. Now this is ready to send to the machine. I'm not going to drip feed this. I'm actually going to load this on the machine. So I'll show you real quick how I do that. Okay, the machine's up and ready. And basically what we're going to do is we're going to set this to edit. And we're going to hit program on this button, on this keypad. That's going to bring up the program that's currently loaded. The last job that we ran was the super mount. So what we want to do is actually click live. There's already a 118 on here. I'm going to remove that. That is actually the one that drills holes and puts tooling plate. I think it's 1/4 20s. So we're going to delete that. And the way you do that on the Fanuc is you basically key in the address. So now we've keyed in op 1018. And then you go down here and hit the delete key. And basically that'll load up whatever other program is in the system. But if we go back to live now, that's going to be gone. That's no longer there. The way that we load it is we go to input output and hit read. And what will happen is this will start flashing input. I'm just going to go around the other side of the machine. As you can see, that it's already done, but basically this just sent the code down and it's already loaded the program. On your Fanuc, I have mine set at the maximum settings, and basically I've got it set at the maximum speed, which is I think 19,200, and that's just changing an option in this and setting the DNC to transmit at that speed. It just makes programming loading a lot quicker. So we have the program now. The next thing we'll want to do is go back over, and we're going to take that tool out and put the Hammer indicator in, and we're going to set a work coordinate system offset off this corner. So I'm going to remount this camera and do that. I'll try to explain it as best I can. Okay, we're going to swap tools out. To do that on my particular machine, you actually have to turn it into jog mode, and it'll allow the tool to be released. Now that tool released a lot of what, you know, just keeping tidy. Usually I'll go up in this BT spindle and just make sure that there's no debris. Mine does have a blow cycle, keep everything clean, but you know, there's always just a little bit of oil or something in there, and I try to keep that really clean. Okay, we've got our Hammer tip in there. Now we're going to align it. I'm going to bring the camera in a little closer so you can see kind of the process that I go through. Okay, we're looking for alignment back here on this corner. I'm going to bring the Hammer down and we're going to do the alignment. You need to know how to do this. There's tons of videos on how to use the Hammer probe. But I'm just going to do this really quick just to show you the process. And where I found trouble at, let me just move this over where you can see it. Where I have the most trouble at, and the one tip that I have broke, you just get in a hurry and you get unfocused on this gauge here. And what you're looking for is that's approaching 0. You want to slow down and set up your machine for the proper thing. And since I've really started paying more attention, then I haven't broke a probe since, and I'm relatively happy. This thing's really accurate. Let me go ahead and get this set up. And basically what I do is I just take a board, a whiteboard, and a dry erase, and we just start writing down values. One thing I found useful too to remember which direction, what you're supposed to be writing down, is always look over at the axis that you just moved. Some machines, their push button are a little harder to tell, but on mine it's just a turn selector, so you can tell which axis you need to write down. So right now we're doing the Y. We'll do the X next, and Z will come last. And Z is the weird one. Z is the one where we actually have to do some math with the probe, because we need to do the tool height on the probe. I don't have the offset programmed into my machine. I plan on doing a macro at some point to automatically calculate that for me. And on all these, I'm using machine coordinates. I've got the FANUC control set to show me all the coordinates. And we're looking for the machine coordinates, which for Y is going to be -4.9021. And now we'll knock out the X real quick. And our X is going to be -14.0245. And there's our Z, and this is the one we have to do the math on. Now, I think I've said this on other videos. You actually want to write down the value that you get, your actual original value, and then do the math on the whiteboard. That way, you know you can go back if there's a problem, figure out what happened. Okay, we got our Z measured. Ended up being -17.9816. If you look at these numbers, if you're doing the gauge height method, what you're looking for is you're going to have positive tool offsets, and generally your Z is going to be your probe length plus, and these are negative numbers, plus the Z value. So this came out at like 11 something, and the probe length is like 6, so that added together is 17. And basically what we're mathematically doing is we're taking the let me get the camera up here where you can see. We're basically telling the machine what it takes to get this close to the surface of this spindle, which is our gauge line. It's not right exactly on the spindle. On my particular machine it is, but if you had a whole shop full of machines, you'd want to set it on something standard, which is the gauge line on the spindle. If you've got one machine, the surface of the spindle will suffice just fine. But basically the surface of the spindle, what it takes to get it to the surface of this. And then every time you put a tool in, it's going to offset that much by the tool. That's how you actually end up with the values. That's how the math works out. I got a lot of private messages about that on some of my other videos, and I'm just trying to, hopefully that explains it. Basically you've got a work offset that's basically telling it, how do I get this spindle centered and flush with the corner of this? And then your positive tool offsets will push that off of the part, the distance required to actually machine the job. So we're going to pull the hammer out now and run this job. Okay, we've got our tool back in. One thing I'll say is, you know, mistakes are always made, and you try to be careful, and you try to, every job that you run, you learn a little something, and you improve your workflow. At this point, I'm pretty happy with my workflow. Add some things, you know, some things come up, but I've said this every video, anytime you run a first program, make sure you cut your feeds and speeds down. I'm especially going to do it because this is a brand new vise. And what I don't want to do is bring anything down into that vise and damage it. You know, at least let it get a few years old before I dig into the surface of it. But so we're going to run this job, and we're going to turn our feeds and speeds down really, really low. Okay, so basically what I've done is I've turned the coolant off, and I've let the head come down in really slow rapid mode, and basically just get down at the machine level. You know, bend down on my machine it's possible, and just kind of look. I can eyeball it and make sure that it's not going to do anything crazy. It looks good, so we're going to go with this. Okay, job's done. We do have a little bit of problem. It didn't quite go deep enough. I'm not really sure how thick that little bit of leftover is. We can clean that up. But all in all, that went really good. That the 1/2-inch 2-flute cutter, we were cutting quite a few surface feet per minute, and this machine really doesn't care. But I'm going to pull this out and clean it up a little bit, and we'll probably run another op just to clean that edge off. Okay, it looked worse than it was. Deburring tool trimmed that right off. It's basically about the thickness of a piece of aluminum foil all the way down. One thing that does tell me, and it's equal on both sides, that means we got a nice square part. I mean, it's level and it's the same thickness all the way across. So this should be a good part, and these blanks should be good. I'm going to pop the rest of them in and run those real quick. And when I get done, I'll set this one aside and kind of show you what it looks like. Okay, I just wanted to show you. I ran all the parts. This is the one that we originally ran. What I was saying about that little aluminum foil thickness edge. You can just bend it easy with your finger, and that'll deburr right off. But that's showing me that, you know, I've got good part orientation on this Kurt Vise. Because basically this is laying really flat. I've already put this back in there and ran an indicator over it, and it's within about 0.003 surface flatness, and the finish is just, there's a little oily right now, but this feels like a mirror or glass. Really smooth finish. I'm going to grab the deburring and I'm going to pull these off real quick, just to kind of show you. This deburrs really easily. And there's the finished plate. But anyway, I just wanted to do a quick video. Today's had a day off, and did a little machining and wanted to show the culmination of a couple things. One is this Kurt DX6 vise. Love it. And we got this finished. This has been sitting around for like a week or so with this backside finished, and now we have the front side finished on 13 of these plates. Be sure to check out my Patreon. One of the goals on the Patreon is later. Basically what I would like to do at some point is release a consumer version of this out. And I'm planning on releasing both the design files, CAD files for the board, bill of materials for this, and all the tooling and stuff so you could actually make one of these yourself. And these are pretty useful. I use these in the machine, toy hauler, razor, anything automotive. Basically, this is, you can consider this the equivalent of 4 36 amp relays. Each output will do about 36 amps, and it actually has current control, and you can do some neat stuff with it. You can you know, do multiple switches. In my toy hauler, I've got 4 switches that activate one output, and it's just a little itty bitty copper wire that you have to run the switches. It really saves you in wiring, and you can do some really cool stuff with this. I had to grab these real quick just to kind of give you an idea. Basically, this tooling plate is going to hold this milled out, and the board will actually end up being, you know, hollowed out, and it'll have a little standoffs and cap screws that are countersunk style cap screws. But this is a tooling plate, and this is the raw material of what I'll use to actually create those. And again, you know, check out my Patreon if you've got an interest in it. You know, be sure to become a supporter. And once we hit 500, I'll release the design for this, and hopefully some more people will start making them. They're pretty cool devices and pretty generic. Anyway, I hope you like the videos, and we'll see you on the next one. Thanks.